Okay, so this is the last video in this lesson, and it's about sums of infinite geometric series. If you remember me talking about it in the last couple of videos, I always told you that series had an ending, and the reason why they had endings is because we could add them all together. But sometimes, specifically with geometric series, you can have infinite geometric series. The reason why we can have infinite geometric series is because if we're multiplying by something that's less than 1, then my numbers keep on getting smaller and smaller and smaller, which means eventually they get really close to 0. In fact, they get close enough to 0 that they have an insignificant value, which means that I can add them all together. So here's the deal. There's a formula for infinite geometric series that's not the same as regular geometric series. So if we know it's infinite, then the formula is S sub n is equal to a1, which is our first term, over 1 minus r. And remember, our a sub 1 is our first term, and r is what we're multiplying by every time. But in order for this to work, your r has to be in between -1 and +1. If it is not in that section of numbers, then there is no sum. You can't do it. It just goes on forever and ever, which means that your sum would be infinity. So in order for this equation to work, we need that r to be somewhere in between -1 and +1. So that's the first thing we have to check when we're doing these examples. Let's start with the first example. So the first example gives us the information that a sub 1, or our first term, is equal to -2, and then r is equal to 1/4. So like I just said, we're going to check that r is in between -1 and +1. And it is. 1/4 is in that range of values. It's less than 1, but it's greater than -1, which means that we can use that formula. So the formula, again, is a sub 1 over 1 minus r. And they already gave us all of the information we need. So we're going to say that S sub n is equal to our first term, which we know is -2, over 1 minus 1/4. And then we can plug that into a calculator. So when I plug that into a calculator, I would get that S sub n, or my sum, is equal to -8/3. So remember, these sums are infinite, which means they're going to continue to add numbers until they get insignificant. Because remember, they're getting closer and closer to 0. And so these sums aren't going to be really, really big. They're actually going to be pretty small. Unless you start with like a really, really, really big first term, because you're still adding all of the answers together. Okay, let's go to the second example. The second example gives us the information that a sub 1 is equal to 4 and that r is equal to 3. So remember, the first step that we have to take in these infinite geometric series is to determine if r is in between -1 and +1. In this case, r is 3. The number 3 is bigger than 1, which means that it's not in that range of values that we need it to be. Because it's not in that range of values, what will happen is that our numbers in our sequence will get bigger, keep on getting bigger and bigger and bigger and bigger, which means when we add them all together and there's no stopping it, it'll just get to infinity. And instead of writing infinity as our answer, we're just going to say that there is no sum, because our r is not in that range of values that we need it to be in order to use that equation. And because it goes to infinity, we don't really know what infinity is. We know infinity goes on forever, but there could be a small version of infinity, a big version of infinity, so we can't just say infinity. We're just going to say no sum. Okay, let's look at the third example. And the third example is that sigma notation. So in this sigma notation, we know that we start when n is equal to 1, but this on the top, it has that infinity symbol, which means that we're going in infinite amount of terms. And then we have -3 times 1/2 to the power of n minus 1. Now we're going to use some stuff that we learned in the last video, where that first number in the that doesn't have an exponent is our first term. And then the thing inside the parentheses, or the number that's being taken to the power, to the exponent, is our r. And then, like we've talked about before as well, this is our n. That infinity is our n. Now, good news, the formula that we need to use doesn't use an n, so we don't have to plug infinity into our calculator. But let me write that formula out. It's S sub n is equal to A1 over 1 minus R. Before we start using this formula, I want to though check that R is within that range of values we need it to be. R is 1/2, which is less than 1, but greater than -1, so it is in that range of values, which is great. And so we can use this formula. So when we use this formula, we're going to have -3, because that's our A sub 1, over 1 minus our R, which is 1/2. And now we can plug that into our calculator, which gives me -6. So my S sub n is equal to -6. All right, let's look at that last example now. The last example is another sigma notation. So we've got n is equal to 1 all the way up to infinity. We're going to find the infinite term. -4 over 5 to the power of n minus 1. Now, if you remember from the last video, when you don't have a first number or a number that's not being taken to an exponent, we can just write, I'm going to do it in a different color just so you can see, but we can just write a 1 right there, which just tells me that my first term is going to be 1. So we know that's our A sub 1. We know that this is our R. And once again, that this is our n. We're not going to really need to use that in our formula, but it's just good to know that our n is infinity, which means we have to use the infinite geometric series formula, which the formula is S sub n is equal to A sub 1 over 1 minus R. But before we can use this formula, we want to make sure that R is somewhere in between -1 and +1. So -4/5, which is our R, is greater than -1, but less than 1, which means that we can use it. It's within that range of values. Basically, we just want to make sure that if you were, I know that sometimes fractions are a little bit harder, but if you were to plug that into a calculator, -4 divided by 5, it would give you -0.8. You want to make sure that whatever your R is, it's just not, it doesn't have a number in front of the decimal. It always has a 0 point something. It can be positive or negative, that doesn't matter. But I can't be bigger than 1. So it has to be like a -0 point something or a +0 point something. It can't be a 1 point something or 2 point something. And so in this case, that -4/5 is within that range of values because it would be -0.8, which means we can use it. So when I plug that into my formula, I'm going to have that the first term is 1 over 1 minus my R, which is -4/5. And then when I plug that into a calculator, I'm going to get, let's see, I'm going to get 5 over 9, which means that the sum of all of the values from 1 to infinity of the sequence is 5 over 9. And there we have it. That's how we use infinite geometric series.